In this part, we're going to be working with division with complex numbers. So let's take a look at our first example. We have 7 over negative 6 plus 3i. So it's in fraction form. But what I want to go before working it out is that it's connected to what we cover in 15.5, working with multiplication and division of radicals. Now here we have in the denominator I, which is equivalent to the square root of -1. At the moment, you don't visually see it right now, but technically we have a square root in the denominator. So just like how we worked in 15.5, where we cannot have a radical in the denominator, we're going to have to multiply by the conjugate of the denominator. So here, we're going to be multiplying the conjugate of what we have in this denominator. So whenever you have an I in the denominator, you need to get rid of it so that way you can only have real numbers in the denominator of a fraction, in any given fraction. So, just like in 15.5, we cannot have radical in the denominator. Same thing with 15.7, where I is equivalent to the square root of -1. We cannot have any i's in the denominator of any fraction whatsoever. To do that, we're going to have to rationalize the denominator by multiplying by the conjugate. So the conjugate of negative 6 plus 3i will be negative 6 minus 3i, and I'm going to multiply that to the top and bottom of the fraction. Now, it is just like how we did with multiplication with complex number. At the very top, I'm going to multiply the 7 to the negative 6 and the negative 3i. So let me write out the top first. 7 times negative 6 will be negative 42. 7 times negative 3i will be negative 21i. Now for the denominator, since we actually have a binomial terms multiplying with another binomial terms, we're going to have to FOIL. So basically, negative 6 times negative 6 and negative 6 times negative 3i. So negative 6 times negative 6 is positive 36. Negative 6 times 3i will be positive 18i. And then next part is the 3i. I'm going to multiply with the negative 6 and the negative 3i. So 3i times negative 6 will be negative 18i. 3i times negative 3i will be minus 9i squared. So that's what's in my denominator. Now, looking at our denominator, the only thing that I can combine like terms are these two. And if you look closely, positive 18i minus 18i, these two terms will cancel out. So my numerator will stay the same, so negative 42 minus 21i over 36 minus 9i squared. Now here we can actually simplify the I square because I squared is equivalent to -1. So let me rewrite that. Numerator stays the same, so negative 42 minus 21i over 36 minus 9, and instead of I squared, parenthesis, -1. And then we can still simplify the denominator, so I'm going to write it over here for more space. Again, my numerator stay the same, so negative 42 minus 21i over 36. Now, negative 9 times -1 will be plus 9, because negative 9 times -1 is positive 9. You can simplify the denominator now. Again, the numerator stays the same, so negative 42 minus 21i over 36 plus 9 is 45. Now after that, I'm going to write it in standard form. So standard form, I'm going to split this into two fractions because we have one denominator. So the real number is negative 42 over 45. Since this is minus 21i, I'm going to write minus and then just 21i at the top and then 45. Now here we can still simplify both fractions. Now for negative 42 over 45, we can pretty much simplify by a factor of 3. So 42 divided by 3, that's going to be 14, so negative 14 over, and then 45 divided by 3, that's 15. So that's our first fraction. The second fraction, 21 and 45 both divisible by 3 also. So 21i divided by 3 is 7i over 15 divided by 3 is also, 45 divided by 3 is 15. So that's going to be my final answer because my real number is first, and then my complex imaginary number is second. So this is how you rewrite it in standard form. So if it's in a fraction, we're going to split it into two fractions. Like so here, at the moment you have a singular number in the denominator. And then always check if you can simplify each respective fraction. In this case we can. Both fractions were divisible by 3. So negative 42 over 45 is negative 14 over 15. Negative 21i over 45 is negative 7i over 15. And that is our final answer. In this second example, we have in the top, in the numerator, 9 plus 7i, while we have in the denominator, negative 4 plus 3i. So, again, we're not supposed to have any i's in the denominator. It's okay in the numerator. So what I'm going to do is multiply the whole fraction by the conjugate of the denominator. So the conjugate will be negative 4 minus 3i over negative 4 minus 3i. I'm multiplying to the numerator and denominator at the same time. So what you're going to notice is that now in the numerator we have two binomial terms multiplying. And at the same time, we have two binomial terms in the denominator. So that means that when we're multiplying, we're going to FOIL twice in the numerator and in the denominator. So let's FOIL the numerator first. So 9 times negative 4 is negative 36. 9 times negative 3i will be negative 27i. Positive 7i times negative 4 will be negative 28i. And then positive 7i times negative 3i will be negative 21i squared. And then we're going to FOIL the denominator. So let me FOIL, starting with negative 4 times negative 4 is positive 16. Negative 4 times negative 3i is positive 12i. Positive 3i times negative 4 is negative 12i. Positive 3i times negative 3i is negative 9i squared. Next, what I'm going to do is that I'm going to combine the like terms, the i's, in the numerator and in the denominator. So in the numerator, we're going to combine the negative 27i and the negative 28i. So first, I'm still going to have my, I'm going to write over here, negative 36. Negative 27i minus 28i will be negative 55i, and then bring down my negative 21i squared over. Here, we're going to combine the i's again. So I'm going to have 16. But what you notice that in the denominator, we have positive 12i minus 12i. So these two terms will cancel out. And then I'm going to write negative 9i squared. And just like before, I need to simplify my I squared. I squared is equivalent to negative 1. So everything else will stay the same. So negative 36 minus 55i minus 21 over 16 minus 9. And again, I'm switching out my I squared with negative 1. So again, I replace I squared with negative 1. So from there, I'm still going to have negative 36 minus 55i, but negative 21 times negative 1 will be positive 21 over 16, and over here, negative 9 times negative 1 is positive 9. Then I'm going to combine my real numbers in the numerator and in the denominator. So negative 36 plus 21 will be negative 15, and then minus 55i over 16 plus 9 is 25. Now, since I have a singular denominator, a singular number in the denominator, I can split it into two fractions because we need to write it in standard form. So, my first fraction is negative 15 over 25. And I'll just put the negative in front of the fraction, which is fine. Since it's minus 55i, I'm going to put minus and then 55i in the numerator over 25. After that, you always check if you can simplify the fraction. In the first one, negative 15 over 25, both numbers, numerator and denominator, are divisible by 5. So we're going to have 15 divided by 5 is 3. 25 divided by 5 is 5. Here, minus the second fraction, the numerator and denominator is also divisible by 5, so let's do that. 55i divided by 5, 11i over 25 divided by 5 is 5. So that's going to be our final answer because our first number is a real number and our second one is the complex imaginary number. So let me box that up. And here's our final answer. So make sure to write it in standard form. So when you're working with division and you have a singular number in the denominator, split it into two fractions, just like how I did over here. And then always check if you can simplify the fraction, which in case we did, both fractions were divisible by 5. And that's what we got is negative 3 over 5 minus 11i over 5.